Alright, this is my lab video for project 1. The setup, we have 2 clamps, one that holds the motor in an upright position and one that clamps a breadboard with the opto interrupter in it. We have a disc here made out of a playing card with a slit in it, so every time the slit passes through, it'll toggle the interrupt. Here we have the DC motor control circuit, just like the previous labs, and the auto interrupter is also hooked up to the butterfly. Pin B or port B, pin 0 is connected to the interrupter and is an input. Port B pin 1 is an output that goes to the DC motor, and port B pin 2 just goes to this little status LED that lets me know every time the slit passes through the interrupter. All right. I have the code here set up for a 10% duty cycle, and I am displaying revolutions per second, not per minute, and I'll show you why shortly. But this is the step that would change it to revolutions per minute, but right now it gets multiplied by 10 because each time period is 10 milliseconds. So doing that 10 times is 1 second, and then that gives you revolutions per second. All right, so this is for a 10% duty cycle. Turn on the motor. It's going. It's averaging somewhere around 20 or 30 revolutions per second. So I'm going to take 20 and then manually multiply it by 60. Yeah, 1,200, which is the value that I threw in here. I guess I threw in 2,400 because I used 40 as my average. 40 times 60 is 2,400. So that's how I was getting RPMs, because I'll show you in a minute. So if we increase the duty cycle to 20, and upload that. You can hear it going a little faster, and the revolutions per second increased. So then I would take that average, I don't know, about like 140, and multiply it by 60, and then that's how I got the next value in the chart for a 20% duty cycle. Okay, so it was 20. You can go up to, we'll jump up to 50. All right. And we look at the revolutions per second, it's about 480, 490, about, jumping around those values. All right, come here, change the duty cycle to 70. Now we're at about 700 revolutions per second. It's kind of jumping around. Jumps around a lot because the time period's so small. Sometimes it doesn't get the full slit in the time period. So let's see, we'll do 90. There it goes. We get as high as 1,000 revolutions per second, which seems high, so I'm not sure if motor can even spin that fast. So I took out the times 60 because the revolutions per second seem to be working, and then manually multiplied them by 60. So that is my project. Hey Doc H, just doing a follow-up video to see if I can get my RPS value down. I tried doing a different calculation of revolutions per second by keeping track of how many times the counter went through, and having a variable to keep track of the time too. Doing it this way, I still get around the same. There's my motor spinning. I still get around the same values for RPS I did at 10% duty cycle. It'll upload 16. Before I was getting anywhere between 10 and 40. So I think this way is a little bit more accurate, but it still gets about the same. Even for higher duty cycles, so I can do 50% here. Getting around 300, 400. Yeah, about 400, which is what I was getting before. I think that the reason why it might be so high is if I go ahead and take this guy off of here and run it again, I'm getting a little bit of noise on my input pin for the opto interrupter, and I think it might be triggering it. And I tried to use capacitors to get rid of the noise, but I had no luck. But I think that might be the source of the high RPMs.